Hello again. Here's question 35 from the 2013 exam paper. Find all stationary points of this lot and determine their nature. Okay, well, the first thing I need to do to find stationary points is find the derivative of those. So the derivative is equal to, I'm going to use the product rule, so if it's the rule I'm going to use, if it's y equals uv, u and v both being functions, then the derivative is equal to the derivative of the first times the second plus the derivative of the second times the first. So here we go. The derivative of x cubed is 3x squared times the second plus the derivative of the second, which is e to the x times the first. And I will factorise that. Take out x squared e to the x common, and I'm left with 3 plus x. That's my derivative. Write my explaining line, that is that at stationary points the derivative equals 0. Therefore 0 equals x squared e to the x into 3 plus x. And I must just now find what values of x make this lot equal to 0. Well, what we've got here is this times this, and for it to be equal to 0, one of them must be 0 to start with. And to make the first part 0, the x squared e to the x, well, if x is 0, that'll make that little equal to 0, so we get x equal to 0. That's from the first bracket. And from the second bracket, well, x equal to -3 would make that one equal to 0. So both of those situations work. Now that's just the x coordinate. I do need to find the points. I'm asking the question for the points, so I must just find what those are. I'll just go over here and do that. So if x equals 0, y equals 0 cubed e to the 0, which is also 0. So the first point is the point 0, 0. And if x equals -3, then y equals -3 cubed e to the -3, which equals -27 divided by e cubed. And that's it. That's it as an exact value. I could find it as a decimal, but I don't see why I should, so I'll just leave it like that. They're my 2 points. Okay, now I have to determine their nature. To determine their nature, I just need a bit of a table. So I'm going to get my, not my x dash, just my x, and then my derivative for different values of x's. I will put in the values that give me 0. Well, I know that 0 is one of them. So 0, when x is 0, the derivative is 0. When x is -3, the derivative is 0. I just sort of fill in the others to find what the gradient is doing in between. We'll start off with a number in between there. -1 looks a good place to start. So x, I might go down a line. X equals -1. The derivative equals, now I just need my derivative equation, which is this one here. And if that's the case, then the derivative is -1 squared e to the -1 to 3 plus x, 3 minus 1. And that is, -1 squared is positive, e to the -1 is positive, and 3 minus 1 is positive. So when you multiply those together, you get a positive. If x equals, let's go to this way now, let's put in +1. Then the derivative equals 1 squared e to the 1 and 3 plus 1. Well, that's positive, and that's positive. They all multiply, and we get a positive again. And finally, I just have to put in a number here. I'll go to -5. X equals -5. Then the derivative equals -5 squared e to the -5 and 3 minus 5. That's positive, and that's negative. So when I multiply those, I'll get a negative. And running out of room, that will give me the basic shape. Once I've got these here, I can now draw in the shape, because a negative goes that way, a 0 goes that way, positive goes that way, 0 goes that way, and then positive again. It's doing something like that. So I've got a minimum here, I've got a minimum at this point, and I've got a point of inflection at that one. Here we go. Just write out what we've got then. At -3, 0, that is a minimum. Oh, it's not -3, 0. Excuse me. It's -3. Oops, just -27 over e cubed. That's a minimum, and 0, 0 is a point of inflection. So that's that. So the method was, you find the derivative, put it equal to 0 at stationary points, find what the points are, do yourself a table of how the gradient is going, and when you've done that, you can decide what sort of things you've got. Okay, that's that.